We're going to simplify some rational expressions. Rational expressions, again, coming from that word ratio, which for us just means something like 5 to 2, sometimes written with a colon, but in math, most often going to be written as a fraction. So expressions that involve fractions. Up here at the top, all I've got are 3 different ways to write the exact same expression. It's incredibly important that we get very comfortable with this idea. The most important one is I want you to be able to take number 2 and think of it in terms of number 1. To recognize a single numerical denominator on a fraction to be the same as a fractional coefficient for the numerator as an expression. And then we can see if we can get comfortable with these 2 ideas, then we can definitely see the relationship between 1 and 3. Here I've just distributed the 1/2. Being flexible with these 3 methods of writing expressions that have fractions in them or that are based upon fractions will be very useful when we come to solving different types of derivatives, as you might want to be able to move back and forth between several of these different forms in order to approach a problem in the most simplified manner. Let's look a couple of examples at rational expressions and simplifying. Here we're going to subtract 2 rational expressions, and we'll remember that to subtract fractions we need the same denominator. So we're going to turn these denominators into tens. For the first fraction, you need to multiply top and bottom by 5, and second, top and bottom by 2, giving us 5x plus 10 over 10 minus 6x over 10. And then we're going to combine our like terms, 5x, 6x, we're subtracting, giving us negative x plus 10 over 10. Now, typically we would leave this like we have it written here, negative x plus 10. Do not be tempted to cross off these 10s because they divide. In order to simplify a fraction, we need to simplify all aspects of the numerator. We would need to be able to take a 10 out of both of the terms in the top in order to do the division in that way. So I would say we'd probably just leave it like that. Second problem is a classic simplifying problem with rational expressions. Right now, there is nothing we can cancel out. Be very careful about crossing out like terms or dividing out common factors. This only applies when it is multiplication in the numerator and the denominator instead of subtraction and addition like we have here. So we are not allowed to simplify fractions in that way. We need multiplication to be able to simplify. So we take the numerator and we rewrite it as multiplication. This is x plus 2 times x minus 2. It's a difference of squares. Divided by, and we can also factor the denominator. This is x plus 5 times x minus 2. And now, since we have the multiplication of things, see we're multiplying 2 binomials in the top and we're multiplying 2 binomials in the bottom, now we are able to simplify the common terms or the common factors if we want, giving us the answer x plus 2 over x plus 5. I already illustrated a couple of the common mistakes, but just to highlight them, most common mistake with this first fraction is to say that 2 divided by 2 gives us 1, and so this is x plus 3. However, if we remember that 2x plus 3 over 2 can be rewritten as 2x over 2 plus 3 over 2, we see the error in this. We're dividing the 2x by 2, but we didn't also divide the 3 by 2, and both of those things must be done. So if you want to write this as x plus 3 halves, there's nothing wrong with that. You could also do x plus 1.5, but typically I would suggest turning fractions into decimals makes an answer less valuable rather than more valuable. There are exceptions to that. But probably the best thing to do would just be to leave it as 2x plus 3 over 2, especially if it was a final answer. The next one you may have seen already if you took a look at the negative exponent video, but here the most common mistake is to take this negative exponent, move it up top, and then a lot of times students are stuck on what to do with the x cubed that is now in the top. Sometimes people will just attach it to the 3, Sometimes people will throw in an extra addition sign there, but neither one of those are right. In fact, what you want to do is think of this as x squared plus 3 times 1 over x to the negative third. Of course, rewriting 1 over x to the negative third as x cubed tells us how to finish out this problem. Distribute it through the parentheses, giving us x to the fifth plus 3x to the third. That's the correct simplification of that rational expression. Okay. The third one here is similar to the first one. The students might be inclined to just cross off the common terms, 2x and 2x. But again, this division can only happen if you apply it to all of the terms. So this thing is not going to be equal to 1 over 6x squared plus 1. Instead, we need to think of this as dividing both the top and the bottom by the common factor. Divide by 2x, divide by 2x. When we divide the numerator by 2x, 2x over 2x is just equal to 1, so the numerator does become 1. But when we divide the denominator by 2x, 6x squared plus 2x over 2x, that becomes 3x plus 1. And so the final answer would be 1 over 3x plus 1, making sure we divide all three terms by 2x. The last one, we've already got a common denominator, so we are subtracting. The most common mistake to get here is, well, x minus x is 0, so we are left with 5 halves. The mistake here being that this subtraction sign needs to apply to both parts of the numerator when we are subtracting. So we could think of this problem as x minus x plus 5 using parentheses to remind ourselves that we're subtracting the entire expression, x plus 5, not just the x because it happens to come first. This should in fact give us an answer of negative 5 halves. That negative 5, the negative sign is a very common mistake in a problem like this. Here are 6 expressions. Some of them you might be combining, you might do a little factoring, simplifying some fractions that involve addition and subtraction in the numerator and denominator. Solve these 6 problems and check your answers on the Google site to make sure that you got them right.